All right, let's dive into something that's, well, at the very core of pretty much all software, data types. It's how we tell a computer what it's actually looking at. Today, we're going to break this whole concept down using CompTIA's Tech Plus objectives as our roadmap to really see how these simple labels make everything, from your phone to your bank account, actually work. So, have you ever stopped and wondered about this? I mean, seriously, how does your phone's address book know that 90210 is a place and that it shouldn't, try to add it to another number? Or why doesn't it try to multiply your name by 2? It seems kind of magical, but the solution is actually brilliant in its simplicity. And there it is. That's the secret sauce. Data types. Think of them as invisible tags or little instructions we give the computer so it knows exactly how to treat every single piece of information it sees, whether it's a name, a price, or a simple yes or no. The best way to think about data types is like a toolkit. You wouldn't use a sledgehammer to turn a tiny screw, right? It's the same idea in programming. You need the right tool for the right job. So we're going to look at the 3 essential tools that pretty much every programmer has in their kit: Booleans, numerics, and text. Okay, first up we have the most basic, most fundamental tool of them all, the Boolean. It's just the simplest choice you can possibly have. It can only ever be true or false. That's it. It's the heart of all decision-making in code, kind of like a digital light switch. And you can see its power right here. That simple on or off state is represented by just a single bit of information, a 1 for true or a 0 for false. That's all a computer needs to know. Is the user logged in? Yes or no? Is the item taxable? True or false? It's so efficient. And here's a perfect real-world example of that. A programmer can create what's called a flag. Let's name it is taxable. Now, if that flag is set to true, the program knows, okay, time to add tax. If it's set to false, it just skips that step completely. That one tiny little Boolean can control a whole financial calculation. Next tool in our kit, the number crunchers. These are our numeric data types. But here's the thing. Not all numbers are created equal in the eyes of a computer. It makes a really important distinction between whole numbers and numbers that have decimal points. So what's the big deal? Well, it's all about how the computer stores them. An integer, like 47, is straightforward, but a float, like 3.14, is way more complex. It needs more memory because the computer doesn't just have to store the number itself, it also has to remember exactly where that little decimal point goes. So that extra precision, yeah, it comes at a cost. And our final basic tool is for handling, well, text. And just like with numbers, we've got 2 different levels. We can deal with just one single letter or symbol at a time, or we can group a bunch of them together to form words, sentences, you name it. You can really see the difference here. A char, short for character, is like one single building block. It's just one letter, A, and it takes up a tiny, predictable amount of memory. But a string is literally a string of those blocks tied together. So its size and memory, it completely depends on how long the word is. Okay, so we've got our toolkit, we have Booleans, we have integers and floats, and we have chars and strings. Now for the really important part, knowing which tool to actually use for the job. Getting this right is totally key to writing code that's efficient and doesn't break. And believe it or not, there's a super simple, pretty much foolproof way to figure this out. Just follow this flow. First, you ask yourself, is this a simple yes or no, a true or false? If it is, bam, use a Boolean. If not, okay, next question. Is it a number? If yes, then pick a numeric type. And if it's neither of those things, well, then it has to be text. See? It's just a clean, logical process of elimination. So the most important takeaway, the number 1 rule, is this. It's all about efficiency. You always want to pick the simplest, most memory-efficient data type that can get the job done right. Don't use a complicated float when a simple integer will do. It keeps your programs running fast and clean. Which brings us right back around to where we started, that original mystery. We've got our toolkit, we've got our decision-making process. Let's solve this thing once and for all. What is the absolute best data type for a zip code? And here it is, the big reveal. A zip code is best stored as a string. Why? Well, just look at that example, 02116. If you stored that as an integer, that leading 0 would just vanish. Poof, gone. Plus, you are never, ever going to do math with zip codes, right? You're not going to multiply 2 of them. A string preserves the format perfectly. Same logic applies to the other examples. A customer visit count is a whole number you count with, so it's an integer. All right, you've got the concepts now. I can feel it. So let's do a quick fire challenge, just to make sure all this knowledge is really locked in. I'm going to ask a question and you think of the answer. Ready? Okay, first one. You're building an app and you need to track whether a customer is in your loyalty program or not. They either are or they aren't. What's the best data type for that? Of course, it's a Boolean. It is the textbook definition of a true/false, yes/no situation. This is exactly what Booleans were invented for. Simple and super efficient. All right, next up. You're working on an e-commerce site and you need to store the price of an item. Let's say it's $19.99. What kind of numeric type are you going to reach for in your toolkit? That's right, a floating point number, or a float. Because it's got a decimal, a simple integer just isn't going to cut it. The float is designed specifically to handle that precision you absolutely need when you're dealing with money. So let's just quickly recap the big ideas. Data types are those essential labels that tell the computer how to handle information. If you've got a yes/no question, use a Boolean. If you're working with numbers, you have to choose between a simple integer for whole numbers or a more precise float for decimals. And maybe the biggest insight of all, always think about the context. Just because something looks like a number, like a zip code, doesn't mean it should be one. Sometimes a string is the better tool for the job. And that's really it. These are the absolute basic building blocks of the entire digital world. They're like Lego bricks. So the question I want to leave you with is this. Now that you know what each of these individual bricks can do, what incredible, complex structures can you imagine building with them?